All right. Good morning, everyone. I'm Eugene. I run the Alliance of Angels, and welcome to our webinar today on understanding the 5G investment opportunity by Jim from the 5G Open Innovation Lab. All right. Thank you, everyone, for choosing to spend time with us today. Just a quick logistics. We would like to invite folks, please, to participate actively. We want this to be an interactive session. If you have a question for Jim, feel free to speak up, right? Or also you can submit questions or comments through the chat or the Q&A panels in this session. So please don't be shy. Feel free to speak out. The more folks participate, the more we all learn together. Right. And however, if you are not speaking and you're not interacting, please ask everyone to stay on mute. Right, so we can keep background noise down to a minimum and everyone can have a great experience. So to start off, I'm going to share a little bit about my organization, the Alliance of Angels. We're a group of 140 angel investors here in the Pacific Northwest. Every year we put about $10 million into 20 companies. Right, most companies that are fundraising from us, they're looking for a total of between $500,000 and 1.5, and our typical check size is 250 to 500. Right? Sector-wise, we're about a half IT, a quarter consumer. The rest is life sciences, hardware, energy, etc. We're actually a sector agnostic investor, also a stage agnostic investor. The hard filter is that we focus on companies headquartered in the Pacific Northwest. Now, in these times, there's always a lot of questions. Hey, are the investors actually investing? But we have found that actually, as we have moved our events virtual, we've actually had an increase in engagement. And our investment pace hasn't really changed significantly from prior years. This year, we've done at least 7 new investments post-COVID. So we are very much in business. If you are an entrepreneur and you're actively fundraising, feel free to send me a note. My email is at the bottom of this slide. Also, if you're an investor and you're thinking about joining Angel Group, I'm also delighted to answer any questions that you may have. All right, so let me stop talking right now and let me hand control of this session over to Jim. We'll share a little bit more about himself and his Open Innovation Lab. All right.
Thank you, Wai-Jin. I appreciate it. And thank you for the opportunity for us to participate today in the workshop. I'm going to go ahead and move over to sharing my screen real quick. So give me a second and then we'll jump into the presentation. All right. I think you could all see the screen. Let's go ahead and blow that up so we can see a full view of it. Great. All right, so welcome to today's workshop for investing and understanding the investment opportunities in 5G. My name is Jim Brisimitzis. I am the founder of the 5G Open Innovation Lab, a journey that we started back in 2018. Just actually completed our first batch of 17 great companies in our inaugural program that started on May 4th, and that batch concluded its efforts last week. Actually, 12 weeks went by pretty quickly. We're in the process of recruiting for batch 2, which will kick off in early September. So for the entrepreneurs and founders on the call, I'd love to take some questions from you around that. But before we do, let's understand what 5G is, get through some of the noise of it, and the reasons why we're excited about this opportunity in the lab. A couple of caveats. My main presentation screen is right in front of me and my camera is on my phone. So if you see me looking this way, it's because I'm looking at the presentation. Other things, if you have questions, as Wai-Jin pointed out earlier, feel free to interrupt and stop, and I'm happy to take those questions and really facilitate some of that learning. So with that, let's go ahead and jump into what 5G is. If you're on the background listening, go ahead and mute just so we can have minimal disruptions. So let's talk a little bit about what 5G is. There's a lot of hype in the industry around what it's capable of, and I wanted to just pull out some of the obvious differences that we'll experience collectively as we move off from 4G LTE advanced networks that are in motion today with most of the carriers here in the United States and into what 5G is. And so at the core, it's speed, it's bandwidth capacity, it's latency performance, it's just sheer access to number of new devices is exponentially growing up. 5G isn't just a faster wireless experience. There's so much more that's happening behind the scenes. So let's take a look first at peak speeds. Today, With some carrier aggregation, that you could clock about 1.4 gig. It's rare, but it's possible here in the United States and around the world. Typically, the average speed for 4G LTE is somewhere between 2 to 500 megabits if you're lucky. In 5G, that is expected to balloon to about 10 gigabits per second, and will continue to get even faster as more and more network densification rolls out. We'll talk a little bit about that later. From a latency performance, latency measuring the amount of time it takes for a data packet to leave the device, go to a data center, and come back, you're seeing about 40 to 50 milliseconds on a good day. That's expected to drop to less than 10 milliseconds, and that's really important for autonomous vehicles or any sort of use cases that depend on that latency performance and, more importantly, even jitter performance. What I get excited about, though, is just the vast scale. So if you look up today at a tower, those radios are typically supporting about 10,000 to 100,000 concurrent connections. And the best way to explain that is if you've ever gone to watch a Mariners game or a Seahawks game, and you're sitting in the stadiums and you see full bars on your phone, but you're having problems connecting to a phone call, or your data speed just seems really, really slow. The reason why that is because the towers that are around those facilities only have so much capacity. Well, in a 5G world, those same towers and the small cells that will deploy alongside them have the capabilities of a 10x increase in the number of devices that can connect to those towers or to those radios. And so that moves from 10,000 concurrent connections to 100,000 concurrent connections up to over 1 million in a square mile area. And that's really, really important, not just for those isolated experiences where we're at ball games or big events and we're trying to connect into the network. More importantly, it's because our world's going to be a lot more connected. Today we're just scratching the surface of connectivity when it relates to our home living. In the enterprise, that's going to get even more exponentially bigger. So I'm really excited about where that's going. On the other side, if you look at the data side of where 5G networks are going, in today's world, about 1/100th of a terabyte per square kilometer is the amount of data that's being created. That's exponentially going to grow to over 10 terabytes per square kilometer. That's because more vehicles, more autonomous operations of factories, a lot more of the IoT experiences that we're going to start to see are going to generate enormous amounts of new data, most of which is going to happen at the far, far edge. It's going to require a lot of computing power in the far edge. We'll talk about that in just a little bit. But the network capacity to actually collect and move that data is also going to grow with it. So on the surface, 5G is a faster network architecture. That's absolutely correct. And on the consumer side, we might see, better consumer experiences. But really where this is going to play out in a big way is in enterprise. What we're really excited about here at the 5G Open Innovation Lab is the ability for developers to really create new experiences that are transforming where the enterprise is going and using 5G and the edge as a major enabler. Now, the path to 5G really requires a few really important steps. Some of this you've already probably read in the press. The first is networks are going to get a lot more diversified, especially when you get into the higher ranges of frequency, what they call millimeter wave. There's a lot more small cell deployments that are going to be outfitted across cities here in the US and in rural areas as well. To get to those higher 10 gigabits per second speeds, you need to have the higher frequencies. One of the exciting developments that's happening with one of our partners, T-Mobile, and the Sprint acquisition is they've got their 3-layer cake. So they got the low band with 600 megahertz. Now the mid band assets from Sprint at 2.5 gigahertz, and they're starting to deploy some of the millimeter wave benefits as well. And that's a really good spectrum strategy for both the amount of distance they can cover, and then in certain denser metro areas, the amount of performance they can deliver through the network. And that's really an area where other carriers are looking to pursue that as well. So network densification is going to be a bigger play in 5G to be able to get to those speeds and all the other great capabilities we covered. The second big thing is billions of new devices, and there's some really interesting stats that I'm happy to start to share with you on that, and some research that we've been looking at as well. The big step forward, though, beyond just faster speeds, better performance, latency and jitter, bandwidth, and connectivity, there is a new set of what they call network functions. The most popular one that you probably hear a lot about is called network slicing, but there's also beamforming, DSS or dynamic spectrum sharing, carrier aggregation. There's a whole bunch of new on the edge network functions that carriers could use to deliver better experiences to their end customers, whether it's a consumer play or an enterprise play. And so for the first time, really ever, carriers are getting a lot more hands-on with how their network performs on the far edge. And a lot of that is really exciting. And a lot of that comes through in 3GPP standards for 5G, initially release 15, now release 16, I think that is coming. And then the big area that I'm super excited about, and I'm excited about this because of my history at Microsoft and essentially being in the enterprise world most of my career, is that more and more enterprises are moving to their own private cellular networks. And we'll touch on a little bit of the stats for that. So when you think of 5G, beyond the speeds and the feeds and all the great stuff that is promised to come, there's a lot behind the scenes that if you dig deeper and look at it, it really makes for some really interesting and compelling developer scenarios that are primarily targeting the enterprise. And it's an area that we're really focused on, really accelerating and building a developer ecosystem around here inside the 5G Open Innovation Lab. So before I move on, are there any questions I can answer? All right, if there are, just go ahead and stop me.
Hey, Jim, I think that there is a question from Krishnan Gopalan in the
Okay.
group chat. Is millimeter wave deployment critical for true 5G realization?
In some cases, depending on the scenarios, yes. In other cases, I think there's a lot more advancements that you'll start to see in the 2.5, and now if you're following CBRS, which is Citizens Band Radio Spectrum at 3.5 gigahertz, there's a lot of performance and new innovation that's happening in terms of spectrum allocation, utilization in that world that'll get you close to those speeds. I'm not a spectrum expert, so I'm really going off of the experiences and all the knowledge that I've been consuming myself with. But in some cases, and certainly in denser cities, the millimeter wave piece, it will be important overall. And I saw another question come through. Wai-Jin, do you happen to see what that question was?
Yeah, it's from Katy, I hope I'm saying this right, Katy Praby.
Okay.
And she wants to know how dependent is 5G on infrastructure build out?
Quite dependent. So we're going to see a lot more densification of the network. Not so much, well, we're going to continue to see the towers that you see today, but with millimeter wave, its ability to penetrate glass walls, concrete, it really reduces at higher frequencies. And so in denser metropolitan areas, and you're probably seeing a little bit of this written up in the press already, but there's going to be a lot more lamp mounted radios, building mounted radios and small cells at the millimeter wave level. That's going to allow for a lot of that signal to reach customers, whether it's the device, an IoT device, a car, or what have you. And so you're starting to see a lot more densification of this network over time. But when we get closer to the end of the presentation, I want to turn a spotlight on just how expensive it is to build these networks out. And we take it all for granted. We sign up for our plans, whatever that plan amount is per month. But behind the scenes, guys, these networks are extremely expensive to build out. And in 5G, the densification is going to make it even more expensive. I'm not sure if you know, but between Verizon and AT&T, and I haven't been able to source the actual amount from T-Mobile, so pardon me for not including them, but between Verizon and AT&T alone, there's 2 million fiber miles between those two networks. Imagine that, 2 million fiber miles. It's crazy, well connected. And if you throw T-Mobile's network into the mix, and then even top of that, you throw the big cloud providers, there's a lot of coverage. And so anyways, to answer the question, there will be a bigger requirement on network densification. My personal opinion, my own, it's not the industry's, is you won't start to see a lot more of that densification happening at least for another 3 to 5 years. What you're starting to see in the press today, and T-Mobile has made a public statement about this as well, they're starting to turn on their 5G networks. And when you hear that, what you want to listen for is when a carrier says they're turning on their standalone 5G network. This is an SA. And not to get too technical, but at the highest level, a carrier's network is made up of the RAN, which is the radio access network, the stuff that you and I will see out in the public, hanging on poles and off the side of buildings. And those are typically connected to a base station, or a base station connects to a central office. So all of the spectrum traffic, the data, the phone connectivity that we enjoy in our phones hits those RANs, that dumps into the base station, goes into the central office, and then out to the core, what they call the evolved packet core of a carrier's network. That's really the guts of the network. Um, that takes a lot of wiring. Obviously, it takes a lot of infrastructure on that far edge. But as you get closer into where the 5G networks are going to go, a lot of that's going to get more diversified, which means there's going to be a lot more infrastructure that's going to be deployed, and that becomes really, really expensive over time. We'll get into that in just a little bit. Now, when I looked at 5G, I took a reflection back into what happened between 3G and 4G. And hindsight is great because when you're in the moment, you really don't see a lot of these market forces playing out. But when you look back 7 years, 10 years from when the transition happened, you start to see some signs that really start to show that there's some really good opportunities. So if you go back to the transition from 3G to 4G, remember 3G was really the commercial introduction of data to our phones. And at the time, the smartphone market was non-existent. It really took Steve Jobs to walk on stage one day in 2007, introducing the iPhone as a way to light that market up. But the iPhone really needed data and connectivity because the whole app model behind what made the iPhone so great was predicated on the need for a data connection to the phone. And when carriers moved from 3G standards to 4G, fourth generation wireless standards, that was a full major step forward in connectivity speeds. We went from kilobits to megabytes. And so all of the experiences that we take for granted today were made possible thanks to the carriers moving from a 3G infrastructure to 4G. The smartphone made it possible to create a developer ecosystem around that. And that's where we saw the Ubers and the Airbnbs and take your favorite company that really, really grew and built trillions of dollars combined of new market value on those platforms. Those were converging market forces that played out. And if you take that same thinking and look at where the things are going today, we're seeing that play out as well in the lab. So the first is obviously in the 5G connectivity side for all the reasons that I shared earlier. But there's other converging forces that are happening as well. And I saw this play out firsthand at my time at Microsoft. When I launched the Microsoft for Startups program back in 2014, we were working with some of the best companies out of Y Combinator and 500 Startups and Techstars and 1871 and Mars Discovery District in Toronto and a few others. And a lot of those enterprise startups were starting to look to computing on the edge for a number of different reasons. Some of it was data sovereignty, others where connectivity on the far edge wasn't even possible. And so if you're an industrial manufacturing startup that was doing SCADA systems and you needed to run your application close to where the manufacturing facility was, well, now you're taking a construct of an application model in the cloud and you're starting to break it down to how does that work on computing in the edge. And so there was interest then, and I would say even more today, of a push to move more and more applications closer to the edge. And no more is that true than the autonomous lifestyles that we're going to appreciate that are already happening around us with Teslas and its autopilot and who knows what's to come. A lot of those services are going to be required to have computing that are nearby. And so there's a big push to edge computing. All of the cloud players, whether it's Microsoft with the Azure Edge platform, whether it's AWS with Outpost and Wavelength, and just recently Google with Anthos, are all making bigger bets on where the edge is going. So it's a bit of a hot market, and it's a converging market force. We're really excited about that. And the second is Industry 4.0. At Microsoft, we refer to this as digital transformation. A lot of larger enterprises that are have business processes based in, I would say, analog means are moving more and more to digital. And the unfortunate situation that we're all in today with COVID-19, it's actually put more stress on companies that don't have the automation in place or rely on analog processes to do what they do, certainly in manufacturing and transportation and in retail and a few other bigger industries. And I'll show you some stats in just a little bit, but the investment ramp in companies investing in their digital transformation journeys is accelerating. And so when you think about 5G connectivity and all the greatness that I shared that's coming, more and more developers are pushing their applications to the edge because that's where the workloads are going to start to demand it. And those workloads, the heavy and deep pockets for those workloads are in the enterprise, who are in the process of digitally transforming their businesses. That's making up for a converging market force of opportunity that we're seeing out. And again, something that we're trying to exploit as part of our mission at the 5G Open Innovation Lab. Any questions on that before I move on?
Could you expand on what the edge is?
Yes, great. So everyone has a different opinion of the edge, and I'm going to throw my hat and suggest I have my opinion of the edge. My opinion of the edge is essentially a set of computing resources that are as ubiquitously available as a cell signal is today, meaning if I have, today it's my phone, but it could be my smart coffee, it could be a SCADA latent industrial manufacturing piece of equipment, whatever it is, I think edge computing is having compute resources as close to those devices and as close to those resources as possible. Today, the edge consists of whatever the footprints are of the big cloud players and their reach. And you've probably seen some of the news of Microsoft and AT&T signing an agreement. I think AWS and Verizon here in the United States, but other carriers around the world have signed partnership agreements with Outpost and Wavelength. I expect certain things to play out with Google and Anthos and other players as well. They're thinking of the edge as an extension of their core cloud capabilities. I don't know what the exact number of data center footprints are here in the United States. Let's say it's, I'm going to take a wild guess. I think it's 20 major data center locations here in the United States, maybe even 100. Let's say it's 1,000. I don't think it is, but let's just say it's 1,000. Crown Castle alone, which is one of the largest, and American Tower Company, which are the two largest vendors of tower owners. And if you look up at the tower and look down below at the base station, those towers have networking compute there. And in 5G, a lot of that's going to be orchestrated with application containers. There's, between the two of them, there's over 80,000 locations across the United States. And what that means is 80,000 locations where you could co-locate compute resources on the edge, and you're taking advantage of fiber to those base stations. That becomes an edge platform. Now, the big question is, if I'm a developer today that's building an enterprise product, could I run that application inside a carrier's network? And that's really exciting for us. So let me move on, because there's a couple other slides I want to get to, and I certainly want to reserve some time throughout our workshop and at the end to answer some questions. So I wanted to set you guys up with just a little bit of background of where 5G is today, things that we're excited about, and then those converging market forces. But given the theme of our workshop today, where the investments are, I also wanted to be upfront around some of the obvious investment areas that we've been tracking to, and then things that could potentially be coming. So the first is in digital transformation. There's over $2.3 trillion being spent on digital transformation by large enterprises, according to IDC. And I have a link to where that report is for you to dig deeper into that. That 2.3 trillion is being spent between now and 2023. And one of our partners in the 5G Open Innovation Lab is Avanade. And Avanade started off as a joint venture between Accenture and Microsoft. And we had Craig Roslin, who's their head of revenue, come in to speak to our batch early on in, I think it was May. And what Craig was sharing then was, due to COVID, a lot of the digital transformation journeys that they had been mapping out with their clients, and these are Fortune 2000 customers and above, a lot of those digital transformation journeys were 9 to 18 months out. And then because of COVID, a lot of those plans actually got brought into the summer. We're talking like 3 to 6 months out. So digital transformation is a huge opportunity. It isn't a buzzword, it's real. And there's real money being invested behind that. So as an investor, if you're looking at companies that are in the digital transformation world, taking an analog business process and helping large enterprises digitize that in areas that, in rather industries that include manufacturing, healthcare, transportation, retail, media and entertainment, there's some big dollars to make investments in that. Again, you're looking at this from an enterprise perspective, not necessarily a carrier or telco perspective. And in all of those scenarios, I would look for the angle where 5G is a big enabler, because that's really where a lot of the goodness is going to come from, the value that those companies are creating. The other area, something I touched on earlier, private cellular networks. More and more enterprises, in a survey that was recently done, I think I have a link to it in my next slide, they were polling CIOs from worldwide and saying, how important are private cellular networks? Now, to be clear, what a private cellular network is, I'll use Boeing as an example here locally. I don't know if this is the case with them, so this is all just an example. But if you look at Boeing's largest building here in Everett, where they build the 777, and for next little while the 747, sadly they've retired that aircraft, but that's 1 million square foot plus facility, and Wi-Fi has been okay for coverage, but it's not the best coverage. And so a company like a Boeing is saying, you know what, we're going to go run our own private cellular network. It's going to be based on 5G standards, and we're going to get all that latency performance. We're going to get all of that speed capability. It's not that hard to essentially set one up. And if we need to, we can partner with a carrier on their licensed spectrum, or as if you've been tracking where CBRS is going, they can vouch to get a CBRS license that is now actively being auctioned off by the FCC. So private cellular networks is actually becoming a growing area of interest, and we see that as a great platform for digitally transforming enterprise startups to actually run the applications inside those networks, particularly in countries like Germany that have strong data sovereignty laws, where those private cellular networks and all the application data that runs inside them has to stay inside the borders of those countries. And so that's a huge area of interest. So far in auction 105, the FCC has auctioned off $357 million. It's been rumored that when the auctions are complete, there could be about $40 billion of new spectrum auction revenue just off of 150 megahertz, from 3.5 gigahertz of spectrum to the 3.75 CBRS band. That's a band primarily owned by the Navy, I believe. The second is in automation. As I mentioned earlier with digital transformation, automation isn't a buzzword. I had the fortunate opportunity, one of my colleagues, John Shuchuk at Microsoft, this was back in 2017, had purchased a Model S. And he and I happened to be in Silicon Valley for some meetings with some of our startup partners. And we used it as an opportunity to actually go do a tour of the Tesla factory. And that was a great day for me, just to kind of see how Tesla is manufacturing cars. And I had also, given my roots in Canada and being from Toronto, I had previously toured GM factories and Honda factories. And what I noticed was a stark difference was that there's far fewer people at the Tesla factory building vehicles. Now, this was obviously the benefit of several years of manufacturing innovation forward, and they just did stuff differently. But I remember touring General Motors in Oshawa, and I forget the town where Honda had its Alliston, Ontario, is where they had their manufacturing plant for Civics that supplied all the Civics in North America. And there's just a lot more people. So automation is absolutely real. And as I mentioned earlier with COVID, a lot of that is moving forward now, where in a situation like a General Motors, where due to health concerns, you're not able to actually allow people into the factories, and for the most part, can actually start to, you can maintain some production through robotics and other new automation technologies and platforms that are being built. So from our standpoint, that's a huge opportunity. And someone asked me, so why would someone build a private cellular network if they can just run fiber to any one of these manufacturing pieces of machinery, whether it's a robot or what have you? Well, the reality is, if you're familiar with manufacturing, and I'm starting to get more familiar with it today, these factories are not static footprints. They're always changing. There could be a new car, there could be something new that they're manufacturing. So oftentimes there's downtime where they're moving particular pieces of machinery around, and by moving it and moving all of the connectivity with it, it becomes insurmountably more expensive and time consuming. When you have a factory site that has been covered in 5G private cellular connectivity, it doesn't matter where you end up relocating any part of that manufacturing machinery, it's always connected to the network. And that means a lot, certainly for manufacturing companies who are trying to be agile and move very quickly. So automation is becoming an area that you're going to start to see a lot more investment in, not just in manufacturing, but in all aspects of the supply chain, from logistics to warehousing to a whole bunch of other stuff. And I think it's safe to say that Amazon on the retailing side has certainly been leading the way in that regard for many years now. Immersive experiences is another area where you could argue in the last 3 to 4 years, the holographic mixed reality, volumetric experience were great, nice to haves, kind of like Space Warsy, kind of fun. We have several great companies that we've had the chance to work with. One in particular here in Seattle called Tactile, that's actually using it as a viable, real platform that enterprises are voting with their dollars and investing behind, where they're enabling frontline workers to capture the great knowledge that they know of operating particular machinery or a process in a plant, what have you, using HoloLenses or Magic Leap devices, and passing that knowledge on to a worker that is just coming through and trying to learn that same piece of machinery. So from my perspective, immersive experiences are actually starting to really cross that chasm of less about it being a science experiment, more becoming as practical as what PCs are to us today in large enterprises. And Tactile is a great signal. It's the canary in the coal mine, if you will, of where that's really playing out. And I'm starting to see a lot more immersive experiences. Peggy Johnson used to be the executive vice president of business development at Microsoft, and she's somebody that, while I was there, was really leading the charge of helping Microsoft transition and think differently about some of its bigger opportunities. Just recently, as you probably read, has now moved over to being the CEO of Magic Leap. Very smart person, I think, sees where this opportunity is going, and I would use that as a testament to suggest there's some really cool things that are happening in the mixed reality world, whether it's augmented or virtual. And in the enterprise, I think it's becoming more and more mainstay. A lot more real critical usage of that technology is becoming part of how people are just generally doing business. So good, interesting crossing of the chasm. Now, on the last point here, non-negotiable security, when we get into where some of the connectivity opportunity is going, all that means to a security expert is that you're widening the threat vector, meaning you have a lot more devices that could be penetrated from a security perspective, and absolutely security is going to be a huge opportunity. It is today. It's going to get even bigger as you get more and more devices connecting to the internet via the 5G networks on the far edge, and eventually through Wi-Fi and what have you. And what that means for corporate America, who's digitally transforming, who's going through more automation, who's probably running their own private networks, and is using immersive experience, just to name a few, that's going to mean a lot more of these environments is going to need to have a better perspective on security, and they're investing behind that. So as an investor, when I think about where 5G is going, signal aside, when you look behind the scenes, there's a lot of real cool scenarios that are playing out that's all driven by where a lot of new investment is being made in digital transformation, and that includes these areas here. And then the following slides, I'll kind of walk you through why I believe these are core opportunities to be thinking about as an investor. One point on the lab, the 5G Open Innovation Lab is about enterprise startups. So we focus on enterprise startups with workloads that will complement or be enabled by where 5G and edge is going. We're not looking for telco startups. We're looking for enterprise companies that are going to take advantage of these opportunities. So that's how we're thinking about it from an investment perspective of our time and our resources and our partners. I wanted to stop there and see if there's any questions I can answer. Wai-Jin, I think I saw a few come through.
There are quite a few. So from Mark Muller-Asperben.
Oh, Mark. Hey, Mark. Good to hear from you again.
Yeah, is the innovation happening in the United States, China, Korea, Europe? Are there trade issues? Given the companies designing Chinese components, U.S. components, and so forth, is the higher U.S. communication cost, would it push innovation to other places, other areas?
So the innovation is happening absolutely everywhere. A good portion of it is happening here. Kurt Steck is a colleague of mine. We work together at the lab, work together at Microsoft as well. We were just chatting about this yesterday, ironically enough, where in some cases, the European telcos, he would argue, are a lot further in terms of engaging that. And it's actually kind of true if you think about it. Ericsson, up until recently, started its own edge effort called Edge Gravity. If you follow where the edge news is going, Ericsson actually threw their hat in the ring in a pretty big way on building Edge Gravity as a capability for telcos. A similar effort was started by Deutsche Telekom and supported by other carriers. I don't know the exact number, but that effort's called Mobile Edge X, if you've heard of that. Mobile Edge X is a wholly owned subsidiary of Deutsche Telekom, and it's another area. So those are two examples of European-based firms that are looking at where 5G is going and starting to build capabilities beyond dial tone and data to a device. And those are two examples of it. So Mark, to answer your question, the innovation is actually happening around the world. I think here in the United States, when we invited the FCC to come in to do a meet and greet with our startups several weeks ago, we asked them, what are the things that you're doing to help really spur the innovation ecosystem? And I mean, no offense to the FCC when I suggest the following, but they said, hey, Jim, there's three things we're doing. We're opening up more spectrum to be auctioned off, so the carriers have access to higher bands of spectrum, 4 millimeter wave, so that's great. We're putting in and we're investing in putting in more fiber into the ground, and that's great for some of the millimeter wave conversations we had around network densification, but more importantly, it's super important for rural America or any rural areas of any country that lacks from the ability to have any real connectivity to their areas. And then the other things that the third thing that they were doing was trying to work very closely with municipalities, city governments, and states on making the permitting process for carriers to deploy more of these radios easier. And that's hard. I don't know what the exact number is, so don't quote me on this, but I think it takes an average carrier somewhere between 3 to 6 months, maybe even longer, to just get a permit to hang a radio somewhere, whether it's on a pole outside of a building or wherever it ends up becoming. When you have a street like Bellevue Way that's going to have 40 to 60 different small cells deployed along that route for however long it goes, just imagine the amount of time it's going to take for any carrier to deploy that infrastructure, let alone wire it and so on and so forth. So I think to answer your question, I think the innovation is happening everywhere. In some geographies, I would argue, and given the conversation Kurt and I had, that perhaps they're a little bit more ahead. They see the opportunity and they're pursuing it. In other cases, there are just some natural inhibitors that are working against the system. And so in that conversation with the FCC, they said, these are all the things that we're doing. What do you think we should do differently? And I'll get into that part of the conversation shortly, but the bold thinking is that it's this ecosystem of founders who are pursuing digitally transforming enterprises in those journeys, creating great products and great solutions and great services, but using those 5G networks as an actual platform to build on. That's different. And if you want to turn on the innovation ecosystem that the United States is legendary for, it's about access to that amazing platform. But that requires a mindset change. That requires you all to think of a telco as not just a voice and data provider, but actually a platform provider on the edge. And we'll get into some of that in just a little while. If it's okay, Wai-Jin, I'll go ahead and start getting to some of the other slides, and I'll come back for some questions if that's all right.
Sure, please go ahead.
All right. Okay, so when I looked at the market, and I think you'll all get access to this as a PDF, anything you see that's highlighted, or sorry, rather underlined, guys, will point directly to the source of that data. So I encourage you, when you get a chance, go ahead and click on those links, and I'll go straight to where the source is, and you can read further into it. But there's so much data out there, and I try to bring it down to just a few really interesting nuggets on why I get excited about where 5G is, and not for the speeds and feeds, but more of the platform developer capabilities that exist. So the first is on IoT. We've heard this buzzword for so many years, IoT this, IoT that. It's somewhat of a fragmented market depending on who you talk to. I'm not an expert in it. I'm just giving you my experiences in working at Microsoft and learning quite closely about the ambitions of IoT there. But the GSMA had published a study back in late 2018 to early 2019. I went back and looked at that study last week, and they actually updated it. They updated it because of COVID and the impacts of COVID in terms of the number of forecasted connected devices. On the client mobile subscriber side, it's the same. By 2025, there's going to be 5.9 billion digital subscribers connecting into the internet by way of carriers around the world. In the same time frame, their forecast for IoT connected devices, whether it's cameras, cranes, cars, robots, toaster ovens, your phone, your coffee mug, whatever it ends up becoming, that's going to balloon to 24 billion new connections. Guys, that's 4 times the amount of digital subscribers. Now, the sheer number of new connected devices is compelling and interesting, but I look at that and saying, holy moly, think about the number of the amount of new data that's going to be generated. As an application developer, think about the access to that new data and the great experiences you can create from the back ends of that. This is something that carriers are going to be seeing front and center before anybody. And it's really, really exciting. So IoT is a huge opportunity, and the expected growth in that market is significant. And you think about where the journey has been with the cloud, oh my gosh, there's going to be some great scenarios, great investment opportunities behind that. The second is Deloitte has been doing some studies on what they call tech and media and telco, TMT, and they came up with a prediction study that's not aged. It's about a month or 2 old, if I remember correctly. And they were suggesting in that report, it's a full report, so you don't have to pay for it, it's online, that at this point in time, there are 7 million active macro cell base stations globally, right? So 7 million of these macro cells that are connecting, I don't know, 3-4 billion users today, and that number is going to grow as we get closer to GSMA's proposal or prediction that there will be close to 6 billion connected digital subscribers. Then they looked at, all right, so how many industrial sites exist in the world today that don't have adequate cellular connectivity? And that number was 14 million. So when I get excited about where private networking is going to go for the enterprise, it's this reason and others, but this is really the big one. As a carrier, this is a boon opportunity. Think about telco as a service. If you just wanted to focus on just connectivity, this is a huge area for the carriers where they can start to sell telco as a service, private enterprising, private cellular networks as a service to enterprises that have multiple sites around the world and want licensed spectrum access or CBRS open spectrum access, but they don't want to necessarily manage their own network infrastructure. They build widgets, not necessarily run cellular networks. So there's a huge opportunity where you can stand up network connectivity at sites today that don't have that connectivity in place today. And that's huge. We're really excited about that. The last piece of this is having been at Microsoft for 13 and a half years before that, at Oracle and PeopleSoft, and before that at Nortel Networks. I've been following Gartner, Forrester, IDC, and all the analysts for many, many years. And I go to Gartner for their predictions and forecasts on what the current worldwide IT spend is. And they actually adjusted their IT spend down slightly, I believe, if I remember correctly. But their current prediction for global IT spending in 2020 is $3.4 trillion. In 2023, IDC is forecasting that global spending on digital transformation is going to be $2.3 trillion. Half of what's being spent today on IT spend is being dedicated to digital transformation. So digital transformation, as far as I could read in all the research, all the conversations that I've had, both on the innovation side with startups, on the investing side with venture investors here in the city and around the country and around the world, and also with large enterprises, it's real. This is where companies are really spending a lot of money, and COVID has put a massive spotlight on why it's important, and in many cases accelerating. So IDC has put out a report that will take you to a summary of the report. And if you want to purchase it, you're welcome to. But there's $2.3 trillion. I expect that number could actually accelerate even more in the next coming months. And so when I looked at the market, I thought, wow, huge opportunity from a connectivity standpoint, huge coverage opportunity as it relates to enterprises moving to running their own private cellular networks, all of the greatness that comes with that. And then if you just look at where enterprise spend is today at $3.4 trillion and parlay that next to where digital transformation spending is going at $2.3 trillion by 2023, only 3 years from now, actually 2 years from now, wow, there's a lot of money to suggest that there's investments in this area. And for the things that I had shared earlier, investment for this as well. So I'll stop there because I want to make sure I'm answering any questions. Wai-Jin, do you mind sharing any of the questions that are there that I can answer?
There are actually a lot of questions. I wonder if folks, do you want to speak up and ask your questions directly?
Yeah, hi, Jim. This is Krishnan here.
Hi, Krishnan.
So my question was around startup opportunities in simulation, planning, and deployment of 5G networks. Is this area a open field, or do carriers insulate this into their own homegrown solutions? And what's your lab seeing in this aspect? Thank you.
Great question, my friend. Thank you for asking. One of our startups called SciVista is actually doing exactly that, helping carriers plan RF planning better by visualizing and taking a digital twin of an area and then overlaying the RF signal performance in that given area to understand how RF signals bounce off particular objects like buildings or other objects. I'm not an expert, but I believe players like a Nokia and an Ericsson have similar offerings. I think that dependency on that type of simulation is even more so, particularly as you get into more denser network buildouts. It's not good enough anymore to just hang a radio off the side of a building and say, okay, this street is covered. There's a lot more planning that's happening today to help carriers and network operators understand how that particular location for that radio is the right particular location for the best amount of coverage. And so I would argue that the simulation space for RF planning and network planning is absolutely interesting. And I don't want to speak on behalf of any of the carriers, but my observation from the outside looking in is I've seen interest from them in partnering in that, in many cases, overgrowing it themselves in their own labs or doing it themselves.
Yeah, thanks, Jim. And the name of the startup that you mentioned, was it called
SciVista? SciVista, yeah, SCI Vista, VISTA.
Okay, thank you.
You're welcome.
Hey, Jim, it's Dan Rosen. As
Hey, Dan.
edge computing and applications at the edge of the network take hold, do you anticipate that's going to wind up being more expensive, less expensive, or about the same for the customers?
That's the golden ticket question, my friend. That really is. I don't know. I don't know. I think if there's more capacity on the edge, so my goal is to eventually build a developer ecosystem where great companies like the ones that are on the call today and others could absolutely deploy their applications inside a carrier's network. And I want to preface this by saying that this is not pitting a carrier against a cloud scaler. That's not the goal here. This is more about complementing it. But I would argue, Dan, that in the early days of infrastructure as a service, something that Amazon pioneered with AWS, Microsoft came out initially, if you remember back in those days, with PaaS, or platform as a service, and then eventually realized the market wasn't quite ready for it, and started rolling out a great set of infrastructure service offerings. But in those early days, what they were doing was competing on commodity. They were competing on storage, they're competing on EC2 or compute, they're competing on a bunch of those lower edge services. Those days are still amongst us. I think the pricing wars have subsided some. And then the cloud vendors have gone up stack, right? So they're looking at higher sets of services that they can start to charge more of a premium for. But what's interesting, Dan, and the reason why I'm excited about this is that the application model, so in a day like 10 years ago, when an application ISV or a startup were to go build something, normally they would build something that sat and rested inside a virtual machine, pulling together its operating system and all the components that would be necessary for the application to run. Well, there's a bigger trend today, and you're seeing it in the news, and you're seeing it in all the developer engagements around the world and here in the US. More and more application providers or builders, startups, are moving to serverless and app containers as the main form of deploying applications. And that requires compute on the edge and some networking, which I would argue today is a commoditized service. So I would argue that I wouldn't see prices going up. If anything, you might see a stabilization of prices. In many cases, if there's a lot more compute capacity out there, you might see a drop in prices too.
Hi, Jim.
Hi.
My name is Ravi Vayuvegula. I've got a question regarding the 5G chipset pricing. So I do know that the Innovation Lab is backed by T-Mobile and Intel.
Correct.
So if we're trying to create an IoT hardware, one of the bottlenecks is the 5G chipset is pretty expensive as of right now. So I'm just wondering that being part of the Innovation Lab, would we be able to leverage the the bargaining power of Intel or T-Mobile in lowering the price of these chipsets?
So let me answer that question slightly differently. It's rumored to be, and my guess and my bet is it's going to happen. But this fall, when Tim Cook goes on stage to announce the latest generation of the iPhone 12, I believe it is, that will be a 5G iPhone, and that's going to change the economics of the chip industry, where you're going to accomplish what you're suggesting, Ravi. It's going to take a force like an Apple to really be all in on that, where the rest of the industry will follow. Truth of the matter is, there's a lot of 5G capabilities today in the chips, and when the scale of the demand maps to where where the inference happens and the economics play out, it'll be no different, in my opinion, of pricing for a 5G chip as it is today for a 4G chip. The problem necessarily isn't the pricing or the volume. The problem is that there are very few carriers in the world today that are fully standalone 5G networks. What you see a lot of, and I was a former AT&T customer at one point. If you had AT&T about a year ago, you might remember they had this 5GE thing on their phone,
Right.
which was hilarious because there was no one. The phone that you had was not a 5G phone, so
Right.
Anyhow, that was a marketing ploy. But what is happening today? And I think Verizon and T-Mobile and maybe even AT&T have said this too, but those carriers are starting to turn on what they call standalone 5G, meaning on the edge, 5G RAN, fully enabled 5G RAN, 3GPP spec compliant, base station, central office, and then the core being a 5G core, that's a fully standalone 5G network versus what they call non-standalone, meaning some aspects of the network are 5G, and other aspects of the network, like the core, are still 4G. So it's not a fully 5G platform. So to answer your question directly, I think Apple moving into the market with a 5G iPhone is going to accelerate more of the network build-outs. We're already starting to see some of that happen. And I think as that acceleration starts to happen and more 5G connectivity is available, then I think you're going to see a lot more of the commodity pricing for the chips, whether it's a Qualcomm 5G chip or MediaTek or whatever the provider is. And we've been chatting with ARM for several months over this. You'll see a lot of that actually start to really drop and normalize out to what we're appreciating today.
Kathy, here, following up on the chip question, do you see any impediments within the actual semiconductors that need to be overcome or are being addressed either by Qualcomm or Intel, either with respect to heat dissipation or speed or footprint?
That's a great question. I'm going to try to answer it based on my scant knowledge and what I've been reading online. I've been doing a lot of reading about this, so I'll try to answer it with what I've read, but I'm not the industry expert, so please take what I say with a grain of salt. I think it's still relatively new, so I think people are still studying quite a bit about heat, but on the battery side, I think people are still trying to, without a vast number of devices out in the ecosystem really to truly do a test, I think there's going to be some improvements on battery performance over time. And we won't know there as an industry until we get there with scale. So that's number one. Number two, we don't have the application ecosystem that's going to take advantage of a lot of the capabilities that are going to be in those chips. And that's going to catch up. That's actually one of the missions of our lab, to build that developer ecosystem. And so that's going to play out over time. It's not going to happen tomorrow, but it'll likely happen over time. And so from an impediment perspective, I think it comes down to scale, just the number of raw chips that are out in the market that chip makers, manufacturers, and OEMs who are building finished products like the Apple iPhone or Google Pixels or whatever the devices are, can learn from the performance of those early chips and then refine the designs over time around those impediments. Battery power, heat is probably two of the bigger ones that I've read about, and then others.
Yeah,
Okay.
Jimmy, this is Kurt. Just one thing to add to it is there's a lot of work going on between the thousands of sensor companies that are building the sensors or doing the actual data collection on all this proliferation of devices. And so there's a ton of work going on between those sensors developers and who are building those and the chip manufacturers. And until those get into real world applications and we start seeing volumes of data, that price performance that we're looking for is going to take some time to develop. And so there's certainly going to be some impediments initially on, but know that that side of the hardware ecosystem between the sensors and the chip manufacturers are working very deeply to try to address those things. Most of that stuff is happening in what I'll call a proof of concept or experimental phase right now. It's when these things start to get at scale that we'll start to see some of that, I'll say, more progressive development.
Yep.
What are the sensors for?
Oh, there's a whole bunch of different sensors out there
Yeah.
on the machinery front for vibrations and a whole bunch of other stuff in the industrial manufacturing world, to basic stuff like temperature, altitude, heat, or sorry, not temperature, time of day, and a bunch of other fun stuff. That's
think of the sensors as specialized pieces of hardware that are actually doing the use case specific data collection in all these devices.
Got it. Thank you.
Yeah,
All right,
I've
so
also seen the encryption and security being pushed down to the sensor.
actually burned into it from a system on a chip perspective.
They're developing very intelligent firmware.
Absolutely.
Okay.
I just did a time check and I realized we're 6 minutes out from the close of the session. I can go on a little while longer, but if it's okay with everyone, I just wanted to cover off on a couple of quick things, and then we can open it up for questions again, if that's all right. And I apologize for some of the delay. So just to recap, guys, 30 billion new connected devices by 2025. If you add IoT and digital subscribers, enterprises are digitally transforming. I'm a firm believer the network is the computer. It's a term that was a saying that was phrased by John Gage, former VP of Chief Researcher at Sun Microsystems from years ago. My friends over at Cloudflare actually trademarked that, and that's really cool. And then if you look at this research, the World Economic Forum did some research on the economic impact of where 5G is going, and they estimate it as of 2035 to be $12 trillion. So when I hear people talk about telcos and wireless as a dumb pipe, I kind of take offense to that, because if you think about the economic impact that's created by this dumb pipe that people take for granted, none of what we appreciate today would have ever been possible had it not been for the investment carriers have made in connecting us all. And in a 5G world, that's going to get even bigger. But there's a chance to kind of change how we think differently. So very quickly, and I don't want to belabor this point, but very quickly, if you look through 1G, first generation wireless specs, second generation, third, fourth, when we got to fourth generation, and specifically in LTE, a lot of the network functions that are talked about in a 5G world started to actually be embedded in the 4G LTE standards. And what that meant was carriers were moving away from fixed function application-based servers, appliances, with fixed function RANs, that you bought a RAN and that's all it did. You bought a core and that's all it did, to more open architecture, x86 white box, virtualized software-defined compute. And this is what I get really excited about, guys, because a carrier, whether they see it or not, they're going to be operating their own cloud environments. You can call that today a carrier's network, but at the end of the day, a lot of that, the open source efforts that are happening today and where the standards are going is all software defined. It's all virtualized, from the core to the backhaul to the RAN and all the front hauls, all software defined. And the dominant platform for which a lot of that's going to happen is application containers, all running orchestration, whether it's Kubernetes, Docker Swarm, whatever the flavor of the day is. That's where that's going. So when I think about this, we think differently here, right? We think the average application developer today is writing applications that he or she is pushing to the public cloud, and then that public cloud application is pushing out into the network. If you're an Uber today, you're writing an application, runs in whatever the cloud is, and then it pushes out to a carrier's network, and that carrier is connecting them to the end users. In this case, it's a mobile phone, but in the future, it'll be a connected tractor in a farm, it'll be a connected bus that's running autonomously, whatever that ends up becoming. The application models, though, are changing in edge, irrespective of where 5G is going. I think 5G accelerates it, but it's all changing. So more and more developers are creating applications that run inside application containers. The carrier's underlying infrastructure is going to be optimized for running containers. They have to run network functions. It's happening, and it will continue to happen. So we look at this and we say, wow, as a developer focused on enterprise, perhaps pursuing the digital transformation journey, of which there's a lot of money to be made and a lot of problems to go get solved, there's a great opportunity to complement what you've built, to run in the public cloud, to run nearby where your customers are on the edge through a carrier's network. That's the goal that we have in really uncovering and building that developer ecosystem here in Seattle with the 5G Open Innovation Lab. The one thing I want to share, and this is probably not lost on all of you, but it's just something that I have to remind myself of every day, is that applications create value. They pull through the platform. You don't go out and buy Windows because you want to buy Windows. You buy Windows because you want to run an application. You don't buy an iPhone because it's a beautiful piece of hardware. You buy it because you need it to connect to applications. Standalone, the iPhone, while it's a good piece of hardware, it's useless if you can run any apps. We learned this lesson quite strongly at Microsoft in the early days of Windows Phone. So applications create value, value pulls the platform. And that's said for anyone who's built an application like Snapchat. Back in 2017, if you followed Snapchat, they, in one of their public filings through the SEC, announced that they were moving their infrastructure off of AWS to Google Cloud, and that they valued that transition and the spend on Google Cloud to be upwards of $2 billion. That's a boatload of money being spent on cloud because of the vast the massive reach of what Snapchat does. Networks for 5G are transforming into software-defined environments. It's happening. If you don't believe me, read 3GPP specifications. It's going in that direction. But I applaud the carrier industry to think differently about the value. So today, where you're providing dial tone and data, the third important pipe is usage, right? Consumption of cloud services on the edge that complements where the big cloud players are today. And that is really an interesting area that we're pursuing, again, building a developer community around. And then the last is around the future of 5G and intelligent networks. It offers this opportunity to transform, right? And there's a term used in this industry called OTT. At the top, you can see it's called over the top. You build an application, you run it in some cloud somewhere, it traverses a carrier's network to where the user is, and you're monetizing that experience, whether you're an Uber or whatever, and you're using the data plans of your subscribers to actually reach your subscribers. But for the most part, that value is transcending the carrier's network and it's going over the top. Our mindset is different. Our mindset is OTN, on the network. So now as a carrier, again, your value is connectivity. And that connectivity is both voice, it's also data, but now you have this opportunity to run some application services on the far edge that take advantage of the inherently quick speed that you have. The carriers have a tremendously fast network, guys. If you get a chance to play with it, I would encourage you to. It's fast. It's secure. A lot of that traffic never touches the public internet. It's always touching the carrier's network. So they've got built-in security. Now, that doesn't mean that you're building applications where you can be lax on your security, but just like the hyperscale environments, you've got an inherent security in those networks, and they're always available. There was a point in time where you almost never heard of a carrier's network going down. You're starting to hear one or two isolated cases, and at the same period of time, you're often hearing Azure West was down or AWS East region was down for whatever reasons. So you have a lot of benefits that are built into a carrier's network that application providers could take advantage of, plus all the other benefits that we've covered earlier with private cellular networks and digital transforming enterprises and the big amount of money there. So when we thought about, the journey of the lab, the journey of application providers in the enterprise, looking at all those market forces and looking where 5G was going, it's an opportunity for us all to think different. And this was a big point that I wanted to make and encourage you all to think about where that is going. And then if you look at the numbers, and I didn't put this up to kind of look at, a carrier's business versus a cloud's business, but if you do look at the numbers, it's really interesting. And I'll end on this real quick. The first is, remember I mentioned that applications create value and they pull through the platform? Well, the orange are their platform providers: Facebook, Netflix, Amazon, Google, Microsoft, Apple. They're essentially platforms. One's a content platform, one's a cell phone platform or mobile platform for applications. Others are cloud platforms. Another one's a social platform for advertising. They're all platforms. And I just looked at those vendors. I went back as far as I could at 2012 and looked at their total revenue. And by 2019, they did about 900 billion, 894 billion. And then I looked at all of the carriers worldwide that I didn't get my hands on that data. It was $1.2 trillion of annual revenue. And then I looked at, well, let's just look at the US. And I know this is a little skewed, so take it for what it's worth. But I looked at what is the debt burden for a carrier versus the three hyperscalers? What is the revenue for the carriers versus the three hyperscalers? And then where's the market capitalization? And you can see that building networks is very expensive. Most of the carriers here in the United States, and this is not just the United States, this is everywhere in the world, carry a significant amount of debt. I believe it's Verizon has $121 billion of debt. They're valued at $265 billion. Think about that. Microsoft has $79 billion of short and long-term debt on its balance sheets, but it's worth $1.6 trillion. And so when I looked at where this was going, I thought, man, this is ripe for opportunity for the carriers to think differently too, because for the most part, they have real estate on their side. They have fiber in the ground on their side. They have the ability to reach a number of consumers out there, not just consumers, but enterprises. And there's an opportunity for them to generate an interesting platform capability that pulls through their platform and creates value, not just for their networks, but for all the customers that they serve, whether it's a consumer customer or an enterprise customer. And this view is just a further indication as you think about platforms and you dig deeper behind the scenes. The platforms are really where the value is created for applications to build that value for them, and they pull through those platforms, and that shows here. So just to wrap up really quickly, there's 4 takeaways. One, there's converging set of market forces. If I've convinced you of anything today, is that we're in the middle of a number of forces that are playing out in many ways to benefit you all as entrepreneurs. And if you're investors, things to look out for. These are hopefully well stated and well positioned from a research standpoint. Secondly, there's a set of short and long-term investment scenarios. The short-term ones are the ones that I covered earlier. But if you go back to the earlier slide, there's a whole bunch of new disruption that's going to play out. And I had a saying in there saying, it's only a matter of time before we figure out the new Ubers are or the old Sears. What I'm referring to is the companies are coming in and transforming industries. Those are suffering from innovation, the innovator's dilemma, to those that are just stuck on their old ways and not wanting to move forward. That's the Sears of the world. So there's a number of investment scenarios. The ones I've mentioned earlier are interesting areas to look into and look around the corners on. They're great. Thirdly, the 5G for us is a cloud. And I think for the carriers, they're going to start shifting their mindset from becoming a dial tone provider to a cloud service provider. It's an active area that we're pretty compelled on here inside the 5G Open Innovation Lab to really pursue and build an active developer ecosystem around that. It's also an opportunity for application providers to think differently. So if you're an enterprise startup wanting to take advantage of where digital transformation is going, I encourage you to start looking into this deeply, because this will be an interesting area where you can create really, really interesting and compelling solutions to problems that exist today and in problems that will exist in the future. And then the last thing is applications create value, and those values pull through the platforms, as I mentioned earlier. And that's our journey, frankly, inside the 5G Open Innovation Lab, is to create that pool, also showing in that journey that carriers around the world have this opportunity to create the extension of their networks that allows for that new value creation to happen inside their environments as well, and that complements where the public cloud is going. So with that said, I'd love to open it up for any questions.
Right. Actually, Jim, we're actually out of time. We're a little
Okay.
over time. So what I'd like to do, we'll end the workshop right now, but we'll also leave some time at the end if folks want to hang around and ask additional questions.
Sure.
And so with that, I'd really like to, on behalf of the Alliance of Angels, really thank you, for taking the time to share all your insights, your expertise on 5G with us. If folks are interested in applying for the 5G Innovation Lab, I believe there's a new cohort coming up in September.
Yep.
So if any entrepreneurs are interested, please reach out to Jim. And with that, thank you very much for taking the time today.
Thanks for having us, Wai-Jin. We appreciate it. And thank you for this opportunity to setting up the workshop.
Thanks.
Yeah.